Hello everyone. Today we are going to see another theory regarding the coordination compounds, their structure and some properties. The name of the theory is crystal field theory or CFT. So crystal field theory is a theory that considers both the metal as well as the ligand as charged regions. So it is an electrostatic model in which the metal ligand bond is considered purely ionic. So metal is there, the ligand is there. Metal, as we know, is here, is in the positive or cationic state. So this has a region of positive charge, and ligand is having either a negative charge or a lone pair or an electron dense region. So the bond between them is purely ionic. Ionic bond means the electrons are being given to the metal completely. So this is the basis of crystal field theory. Harmonic ligands are ligands in which there is a negative charge. For example, Cl minus, Br minus, etc. And there is neutral ligands where there is no charge on the ligand molecule, but they can donate their electrons via a lone pair of electrons. For example, water molecule, ammonia molecule, etc. So both these ligands are considered as points of electron density. Anionic ligands are considered as point charges, means they are considered as a minus charge. A molecule having two polarity or two charges, like there is charge separation. This is known as dipole. Nuclear, for example, for water, two lone pairs of electron, and because of the electronegativity difference between hydrogen and oxygen, oxygen has a slight negative charge and hydrogen has slight positive charge. So this such molecule is known as a polar molecule. So neutral ligands are dipoles. So they are considered as also like this, point dipoles. This is about ligands. Now coming to the metal. So we know d orbitals in the metals are taking part in the bond formation. There are 5 d orbitals, namely dxy, dyz, dxz, d x square minus y square, and finally dz square. So the speciality of these d orbitals is that they are having same energy or they are degenerate and are symmetric. So when a ligand is coming closer to the metal, what happens is that these d orbitals interact with the negative charge of the ligand, as a result of which their degeneracy is lost. They are no longer of the same energy. Some of the uh, orbitals will have an energy rise because of the interaction with ligands. Some of the orbitals will lose their some energy and they get lesser energy than the normal degenerate level because of the interaction with the ligands or ligand negative charge. Hence, we can say these d orbitals are split. First, when there is no ligands, they are together like this. When ligand is coming closer to the metal, these d orbitals are split into different energy regions. And the splitting is dependent on nature of the crystal field or the geometry of the complex or the hybridization in which the atomic orbitals are adopted. Okay, these are the main points to remember in crystal field theory. Now we will see how this energy splitting is happening. The d orbital splitting is happening in different geometries. Before that, we will see the geometry of d orbitals. So d orbitals geometry is given here. So d xz has this geometry in which the orbitals are between the x and y axis. Similarly, dxz is like this. The orbitals are present in between z and x axis. Yz is like that. The lobes of the orbital are in between the axis of z and y. Now coming to dx square minus y square, the shape is kind of similar. The difference is that in this d orbital, the lobes are in the axis. Lobes are in the x, y axis, not in between the axis as that of these first three cases, but in the axis. Along the axis is the direction of the orbitals. Now coming to dz square orbital, here the shape is like this. One tumble is along the z-axis, in that z-axis, and a ring of electron density is there around the point, the origin of these three axes. So this is the geometry of dz square. This geometry, the position in which these orbitals are there, is playing an important role in it. So three are in between the axes and two are along the axis. So that is main difference. So these three will have different kind of, same kind of splitting, and these two will be having energy different to the first set. How this geometry is important in the crystal splitting is observed when we go further into the octahedral crystal splitting and tetrahedral crystal splitting in further classes. So if you have any doubts up to this point, please ask in the comment section. Thank you for watching. The octahedral crystal splitting as well as the tetrahedral crystal splitting will be uploaded very soon. Thank you for watching.